And we're live. Hello, hello. Okay, the stream preview is tripping a little. How's everyone doing? How's it going, Frothy? Yeah, I guess I'll just get on with the leetcode daily first. Hopefully this doesn't take too long. I swear it always takes like a year and a half. But yeah, after that, then we'll finally finish the chapter in the, I think it was chapter 5 in the kaleidoscope tutorial. It's just for loops left in that. I did if statements last time. Oh. Yeah, Loki, I have a pretty bad history of being late to my streams, even across what, 2 weeks now? It's day 14, wow. 14? Yeah, 14. Wow. Yeah. Thank you all for your support just on the stream. Even just like starting 2 weeks ago, I was skeptical that like I'd even have like any semblance of viewership. So it really means a lot that y'all are it really means a lot to me that y'all are here and willing to listen to me struggle to read documentation. Okay. Okay. Delete one element. As long as it's not empty subarray containing only ones. Okay. I feel like I could sliding window this or something. Just gonna try and speed run through this. Let's just make Rad's the thing as well. Okay. So how do we sliding window this? Actually, we could probably even just start with this even. Actually, no. I feel like I'm overcooking. What do I throw into here? So we want it to grow until I guess let's get a current variable going, I guess. Do we need a current variable? Yeah, we do. So let's and then maybe we should get like a num zeros. So we grow it until we get a oh, we must delete one element. Okay. So then So let's go until we hit nums, 2 num0s, and then I guess we shrink the left side until we're back to 1, I guess. Yeah, I guess that makes sense. And then we can handle this must delete one element case later. Or we could just add num0s. And then if I don't know, we'll see. We'll see. Let's perhaps I will code this up first. So if nums of R is 1, then this is a boring case. So then cur plus, and then continue. So then otherwise this is 0, so then num0s plus equals 1, or plus equals 1. Whoops. Increment that, and then while num0s is greater than 1, we should take a look at nums L. I keep forgetting to put braces around things. I'm too used to doing leetcode in Python, I guess. That's pretty funny. So if it's 1, then we cur minus minus. And then the else block will be num0s minus minus, I guess. So we shrunk the window. So this has to be valid. So then res equals min of max of res and cur. Okay, this should be a good start, and then we need to handle this edge case. Sources say no. So cur. Oh, right. Yeah, that's not how math works. So am I tripping? Let's make this more compact. What is this handling? Interesting. And what is this missing? Why is this 2? And yeah, this case obviously gets it wrong. But why is that 0? Wait, that makes less sense. If it's 1, then we add to cur. Oh, we never set it there. That's why. So then this should be one too long. Oh, that one's correct. Maybe you can store subarray lengths. I mean, I guess I could, but that might be easier, yeah. Also, I've gotten feedback that like when I like look up at my chat, it looks like I'm rolling my eyes. I promise that I'm not doing that. It is just like my setup being a little bit scuffed. Because I'm like literally coding off my like laptop, and then I have like monitor up here, so rest assured I am not annoyed. It's just the setup's a little bit silly, I guess. I feel like I could do something silly with just like num zeros even. Let's see. Yeah, let's get rid of cur. Yeah, I can even do something really gross here. And then we need to scrub cur from existence. And then this would be r minus l plus 1 minus... Oh wait, no. It would just be r minus l, I think. Yeah, because we need to delete one element regardless. I think that would handle that. This is not compiling in my head. Yeah, this is very much adjacent to it. But at the end of the day, I still need to like worry about interviews, so that's kind of how life is, I guess. Okay, this handles these cases now. So I need to handle this now. Num zeros plus plus. This is 1, 2, 3, 4, 5, 6. This should be the longest. Or wait. Oh yeah, minus the 0 would make it 5, but how's it getting 8? I guess that's the entire length. Oh, I'm not moving L. Actually, no, I do need the braces around this. Once again, burned by premature optimization. There we go. Okay. Okay, that. I don't think there's not much else interesting to really say about this. So, luckily this didn't take more than half an hour. let alone 15 minutes, which is a rarity for me, at least. It feels like the leetcode problems always take an eternity. So we have this done. Now we get to go back to fun kaleidoscope land. Yeah. And then kaleidoscope. And we're on chapter 5. Okay. So just as a quick recap from last time, we added for loops. So we have this Fibonacci test. Or no, last time we added if statements. And yeah, if I run build compile or kaleidoscope, and then I pass in tests, fib, and then I go to the file generated. Oh, I need to disassemble it. And it generates if statement code. I don't know how to resize without using mouse. Unlucky. Yeah. So we have, oh, this one's opt, I think. This has the entry basic block. There's the return with the condition, and then else down here. Or this would be the return block, which is interesting to me because it gets like optimized. Or like if you remember the structure from last time, we explicitly built like the diamond shape structure of the basic blocks, or the control flow graph. So here it literally gets optimized away with, I guess, the early return, which I guess makes sense because I don't think there really is any other way to make the IR make sense, because return is a terminator, so that like literally prevents further instructions there. I guess more interestingly, if we were to, instead of let's get rid of the files first. So then if we pass it in with as input instead, it evaluates properly, I think. Yeah. Because the fifth Fibonacci number is 5. Let's give it more things to print out. There'll be a nicer way to do this later once we happen to add for loops. Yeah, let's just do that for now. Yeah, there we go. It prints, yippee. Do you mention the label name when you are creating the basic block? I think I do, yeah. This would be in AST because code gen. Yeah. So this would be if cond. This would be then. This would be else, and then this would be if cont. Oh, I can't. Wait 1 second. Okay, yeah, we're just fat fingering Vim. That's unlucky, but yeah, these have predefined names at least. So I'm assuming it's just the optimizer that's nuking the existing names. I guess I could run it. I could rebuild this without the optimizer, and we could see what happens. Yeah. and we just pass the file in directly, and we LVM dis. Oh, because it's get ignored, it's not found. Yeah, here we go. Interestingly, it's still... Where's ifcond? Wait. Oh, wait. Cond, yeah. Oh, wait, I'm stupid. Wait, then. And then ifcond. Interesting. Okay, yeah. Yeah, I forgot how to read these for a second. That's my bad. So it checks the comparison in ifcond. Oh, this is a little bit yucky actually just to look at, because they're making a comparison and then we're comparing that to 0. But luckily that gets optimized away. So it checks ifcond, and then if it's true, it goes to the then block, which just skips. And then otherwise, it goes through the else block. And yeah, this is just it's just like the standard recursive slow Fibonacci. And then this phi node here joins the two branches, and then it returns the value. So a lot of this gets optimized out, it appears, which is good and intended. The example SSAR, oh yeah, I guess this is already SSA, yeah, because there's like 1s and 2s. There's something else I wanted to point out, but I forgot what it was. Well, if it comes to mind later, I'll do that. So anyways, we have, so that's all the stuff from last time, I guess. So now we finally add for loops, and hopefully we can get rid of this mess down here. Yeah, I'm wondering why these anonymous ones get deleted with optimizations. It's not here, it was compiler. I think those function calls got deleted at least. I wonder if it's just like a flattening thing. Yeah, because the only function that exists here is just fib, and all the anonymous functions are also nuked. Yeah, I'll worry about that some other time. I have some ideas for how to resolve that and just like stick everything into main, but I think I did like peek ahead in the tutorial, and I think they have some ways of figuring out how to resolve that. So I'll figure that out when I get there. But in the meantime, I would like to avoid rewriting so much code. So it's about time I implement for loops. Yeah, this is definitely some semblance of syntax. What did you think of today's LeetCode Daily? I thought it was alright. It felt like a very standard sliding window problem. So it's like, it is what it is. I think the types of problems that I dislike specifically are just the ones that require like really obscure algorithms. Like I think um I think the biggest one was, or like the biggest sort of group that kind of irritated me was sort of like fast and slow pointer problems, because I think in general they're just not really taught. Um, Wait, what is the syntax? Wait, I'm so confused. Uh, okay, and then in. uh, this is great. Um, okay, so I want to see how much of this I can do um without looking at the tutorial and then cross-checking against it. Put char d. Okay. So it'd be the same process in theory. So we'd need to extend the lexer. So let's go here. We need 4. And then we need in. And then, oh, I need to save. And then in here, we need to read it in here. Four, and then this is 4. And then this is in. For me personally, signing window and stacks are the least intuitive. That's fair. I feel like it's a lot of just like pattern matching in my head, at least, in the sense that like I only recognize them because I've seen like similar problems before. I think in general it's a little bit awkward to derive those from just like the brute force solution. There are semicolons but no braces. I'm just as confused. I guess like this is kind of a functional language right now, so I guess it makes sense that like there's not really any like sequential execution in any sense. But I assume that that'll be resolved pretty soon. Because I think, because there's some, after peeking ahead in, I think it was the part 7 where we add variables, there's a couple like memory accesses. That's the sequential equivalent. That's really annoying. Can you share the link of the doc which you're referring currently? Yeah, it's. Let me just put it in chat. Get the correct root page for this. Yeah. There we go. Okay, so we've extended the lexer, I think. I think I did that correctly. I hope I did it correctly. So now we need to extend the AST to support this. So then we can just put this here for x for AST, and which extends public x for AST. And then what does this need? So it needs a constructor. It's a unique footer of type x for AST. And then this is the... Oh, actually, this is a little bit complex. I'm gonna peek at this. Yeah, okay, there's actually quite a lot. There's a var name. How many hours do you learn per day? It's pretty much all the stuff on stream, and then... So it's like the 2 hours on stream, and then I used to watch YouTube from like 11 p.m. to like 3 a.m. and I realized that low-key it's kind of a waste of time. So I started like reading through compiler books in that time. So I'd probably say like 3-4 hours maybe. And I think I might do something similar to this when I start to teach myself data engineering and or C++. It would be a fun way to stay accountable. Yeah, I think that is definitely the biggest benefit of this for me. And Aiden has also been like a really big inspiration for me as well, just to even get started streaming. So yeah, I strongly encourage everyone to try to do this sort of thing if they feel inclined to. But also, like, I also recognize that's not like for everyone, so that's like fair enough if you don't want to. Next semester course load is apparently scary enough to make people gasp. Yeah, I mean, fair enough. It doesn't even need to be like a very long stream every day even. It could even just be something as small as just doing the leetcode daily. And just calling it a day. There's like this guy on YouTube which is like installing Arch every day, which is like pretty funny to me. Also, Aiden's streaming. Go check him out if you haven't yet. What am I looking for? Installing leetcode, or leetcode? Installing Arch every day. Yeah, it's this guy. But yeah, the bottom line is just like if you do something consistently, you'll generally get results just because of the persistence that takes. And if you don't, well, you've done something for a decent amount of time, and you just keep going, and life is good. I'm gonna steal this constructor, or steal this AST declaration, because this is not particularly interesting. Yeah, we're just gonna speedrun through this. This constructor is so ugly. What do we... okay. Okay, this is fine. Our name is the reference. Also I'm not sure how much experience I'll have with C++, but what do y'all think about unique pointers? Or it's just like smart pointers in general? Because I don't really know what to think about them. Oh, you know it's bad news when Clang format does not want to format. Yeesh. That is definitely a constructor. Supposedly very important for latency sensitive systems, just what I've heard. I think that makes sense. It feels like... I guess the thing that confuses me is like... I guess like... there is some degree of overhead just inherent to smart pointers. So you'd expect them to be like... I guess like... less encouraged just because of the degree. Like just in the sense that like multiple like many of these add up eventually at some point. But I assume that just like the general safety guarantees that they provide are also quite valuable. What am I missing? Cogen. Yeah, this looks good. So then let's throw this in here. ast.h. That's not the right key. For expert ast. Var name, and then start is the move start. And then end is the move end. Step is the move step. Body is the move body. Oh, that formatted quite nicely. Reportedly, quant firms have made candidates implement them from scratch in some interviews, so they must mean something. I'll get back to you once I learn the language. That's fair enough. Yeah. Yeah, I've heard something similar. I don't really intend on getting too into quant, but I sort of like loosely follow because I figured it's at least good to have some awareness. Smart pointers, yeah. It's like unique pointer, shared pointer, and then I think the other one was weak pointer. Yeah, weak pointer. Is there anything else I need in this? I don't think so. This seems fine for a constructor. Let's hide the parser stuff. Yeah, I should add to the header first. This looks really funny to me. So this would go under here. So parse for expert, and then oh boy. This is parse for expert. All right, what does this expression look like? So we have the for, so we want to eat the token first of all. Then can you move the parse function to the end like this did sequence? I'm not sure what you mean. I'll just leave this up here. I guess I don't really have too much of an idea of like what proper grouping would look like. Okay. So we have the for. We want to parse this. I forgot how we get the string literal. I think I just stole it from the lexer. That's how I did it. I definitely do it somewhere down here, I think. Expression? No. Oh, it's here, yeah. So we steal that. Parse expression rests in the middle of the ASTs. Oh, this is... I guess this is supposed to be grouped with parse expression as like a helper, because that's like the... I forgot what it's called. I think it was like some sort of recursive parse, but that's like the... I guess the helper to handle parsing like the arithmetic operators. You looking for a job? Yes, I am very much looking for a job. Do I need to check if name exists? Let's see if I need to check. Yes, I do need to check. We need expected variable name. Oh wait, I see. This should be log error. There we go. How long have you been programming for? C++. I've started. I technically started, I think 2 years ago, but I guess 3 years ago now. Damn, 2.5. But I've only like seriously gotten really into it starting like this past year. In general, I've been programming for like 4 years, I think, roughly. We get the variable name. And then what else do I add? I need to eat the equals, I think. Thank you, Warm Buffet. That means a lot to me. How am I supposed to handle this equals? Oh wait, duh. I handle it like the parentheses. It's like here. It's cur token, then eat it. Yeah, so then we eat the token. And then we need a number. What types of expressions does this take? Just primary? Let's see. I will have to look at this. Just expression, sure. So then we want auto. What do we call this? I will just keep this up, I guess. The start. explicit parse expression if stars in null pointer. And this already handles the error, so then return null pointer. We want to, I think that already gets next token. We eat up a comma. So we've gone through for I equals 1 comma. So now we have another expression here. Do you commit the code on GitHub? Yes. When do you consider using auto instead of explicitly typing it? Honestly, it's mostly just a convenience thing for me. I feel like ask me in a year, I'll probably have more concrete rules on when I do it. But for now, it's just like if I'm lazy to figure out what a type is, or if there's a chance that the type is like, if there's a chance that the type will change for like maintainability reasons. This is not start. This is condition. This is the end. Yeah. Then return no pointer. This is not particularly interesting. This is just more of the same slash. This will be interesting actually, because I think, yeah, the step value is optional. So how does it handle it here? I see. It checks for the comma. Okay, that makes sense. Okay, and then I assume it goes to the default value later. I didn't look too closely. If it's a comma, then we want to parse this. And we can't use auto here because we need to keep the thing. So we want, what type is this? Stood unique pointer expert AST. This is step. And was there an else block on this that handled it? Okay, I guess it's implicit. That's interesting. Okay, so then let's see, where are we at now? We have this, and we have the step optional. So now we parse the in keyword. Then we log an error. It should be after start name. Sure, start variable. And then here we can return log error. Return log error. Expected in seems a little bit awkward. In after for, sure. And then we parse the body. In today's episode of copying the same boilerplate. And then now we return stood make unique. And this is a no, I don't need to check that. Okay, it is just a 4 here. Yeah, that makes sense. Yeah, because we need to pass the stuff in. Yeah. So then we pass in. Let's get rid of that. We need start, move. Wait, we move start. What did I call the variable? Name. Okay. Fair enough. Start, stood, move, end, and then stood, move, step. Oh, and then I guess we handle in codegen if it's a null pointer. Do I need to cast it? Is that what I'm missing? Body, that's what I'm missing. Is this hyperline? Yeah. Yeah, I spent way too long messing with my dot files. I figured it's about time I start doing real work. So anyways, I decided to keep messing with them. This should be good. And then, okay, yeah, we stick it in here. That's fair. Okay, figured it out. Now we code gen. But before I code gen, I'm gonna run to the bathroom real quick because I'm staying hydrated. So yeah, I'll be right back. It should be like a minute. Alright, I'm back. Oof. How long does the battery last compared to Windows if you used it? Currently battery... Yeah, let's unplug this and see what it says. On Windows, it was like 2 to 3 hours on regular usage. On this, we'll give it a second. Okay, well, I guess I'm literally running OBS, but usually it's like, I think just with like light web browsing and having a code editor open and maybe like a couple other applications, it's like 4 or 5 hours maybe. It's definitely no Mac, but it's at least like a little bit better than Windows. Although my other laptop, which also has Arch on it, it has a Dedi GPU, so that also nukes its battery life a lot. I don't think like, I think the more I looked into it, the more I realized the battery benefits of just running Linux were more of like a win more sort of thing, where if you had something that already had decent battery life, it would extend that, but it's not gonna like magically like quadruple your battery life or anything. For like that type of gain, I feel like at that point just like switch to a Mac and call it a day. Oh right, CodeGen, that's where I am. So we just finished the parser and the AST for parsing for statements, for loops, for statements, for loops. So now we need to head back up into here and then do CodeGen. Hey Zarun, how's it going? For AST CodeGen. Oh, I forgot to give it a type. LVM value, and then it's the pointer. Big V. Okay. Oh, this is this is gonna be fun. Okay, so the entry heads into the loop body. Oh, and then the conditional branch at the end either heads back up or it heads to the after. I might actually just throw this into... There's a thing to generate the CFG. Opt generate CFG. Is there any other boilerplate I'm missing? Yeah. Why isn't this defining properly? Or why isn't this syntaxing properly? Let's just do this. In my university, there weren't enough charging slots and my laptop always died before the class began. That's so fair. I can't say I didn't run into the same issue. So I kind of just like, for the most part, I was just anchored to walls. Switched to Mac and installed Asahi on it for quite some time, but now I got used to macOS. That's fair enough, yeah. I imagine that like macOS is also just like substantially more optimized for the hardware. And I think there's also like, I also don't think Asahi's able to support the newer M chips. I could be wrong though. What's this? G. Only. Then. What happens if I do this? Yeah, M2. I think that's what I read if I remember correctly. Okay, well I'm too lazy to generate the CFG here, unfortunately, but yeah, it would point to itself here, I guess, in the loop. I could scribble something real quick in GIMP. Now that I think about it. So we go into like the entry block. Touch screen, God bless. Entry. Okay, this is a little bit scuffed, but this is fine. So that goes to loop. Oh, okay, okay. GIMP is not my friend right now. Let's just make, this is entry. This goes to loop. And then one arrow points back into itself like this, I think. And then the other one goes to after loop. I think this is how the CFG is supposed to look. So entry, loop, and then after loop. Yeah, 8 gigs for the air is tough. I think now it's like, or I think it's like a unified RAM as well, right? So I think the newer models are like more generous because it's unified RAM. Yeah. And then just like having it all soldered is just tough. Something about Right to Repair. I used to care a lot, and then I stopped watching Louis Rossmann. So, sure. Oh, OBS did a thing. Whoops. Stream reconnecting? Okay, stream reconnected. We're good. Okay. I love OBS. Okay, so then let's just steal this for now. This goes in here. But it's not conned. It's oh no, we don't even start with this. I think it just unconditionally goes to loop, right? This feels wrong though. This is like do while. Okay, I think I should actually pay attention to this more properly. Where does the fee live here? Oh, it's at the top. Okay. Why do you use both CMake and Makefile? It's because CMake is low-key annoying, so I just have a Makefile wrapper around it. That's literally the only reason. Where you belong, bro? I'm in the US. I float across the country for school-related reasons. Okay, so let's nuke all of this, I think, and then... Huh. Okay, cool. So... we code gen, start, if this doesn't exist, we return null pointer. This is LVM. Next step is to set up the basic block for the start of the loop body. The whole loop body is one block, but it could be multi. I see. Okay. So then LVM function builder, and then we, oh yeah, this is the same as before. Does it have continue and break? I don't think this language currently supports that yet. I assume like they wouldn't be actually, I wonder how they would be implemented. I guess they would just be treated as branch instructions, but I imagine they wouldn't be that hard to implement. I think the bigger reason for them not existing in this state is because we don't really have like a continuation. It's a little bit it would lead to like really trivial loops in this state, I guess. Sorry to interrupt. Can you define the compiler role? I don't know. I'm a noob. That's fair. It is kind of just like a vague term. I don't particularly have a solid definition on it. For now, I'm kind of just defining it as a role where I get to work on compilers, whether in an internship capacity or in a full-time capacity. Basic block. Okay, so now we find the block, and then we create that basic block. Okay. And then okay, this is the explicit fall through. Okay. Basic block. Prev, I guess. Get basic. This should be big G. I'll get insert block. Whoops. Some loop is VM basic block create. So this takes in context, it takes in the label, and then it takes in function. And now we create the explicit fall through. Create branch, and then the destination would be loop. Oh yeah, okay. Oh yeah, it's loop basic block. now we create the actual block. And that's the unconditional branch. Okay, this seems very similar to the if stuff, which I guess is kind of expected. So, builder. And we create, set insert point. This goes into the loop. Yeah, and then the fees at the top because we don't have variables yet. This is var. So then we create the fee. Okay, so then you get a double type from the context. Then we need, so it takes, there's two branches to join, and then it takes name, var name, yeah, var name. Okay. And then we add incoming. Okay. Oh, this needs to be LVM. Whoops. And then we add start val and then prev. Wait. Yeah, okay. So that's one of the two incoming pairs. Yeah, that makes sense. Oh, okay. Something about shadowing that we need to worry about. So that is named values. I remember making that. Yuck. Our name. Oh, I see. Okay, I see what's happening. Yeah. So we're taking old val from, so I guess we're just kind of, this is kind of just dealing with scope, I think, is what's happening. Because this new variable within the if statement, so it'd be I in here in this for loop. Where'd this go? It's here, yeah. So this I, there could be like a variable declaration elsewhere that also is I. So we need to, at least in the loop body, resolve I to this I rather than the external I. But we still need to restore after the loop, so we save it temporarily in old val. Yeah. So now we cogen the body. That's pretty standard. A for loop introduces a new variable to the symbol table. This means that our symbol table can now either contain function arguments or loop variables. To handle this, before we codegen the body, we add the loop variable. Oh, this describes everything above. Well, whoops. Once the loop variable is set into the symbol table, the code recursively codegens the body. So allows the body to use the loop variable. Okay, that makes sense. Does the extern keyword already implemented? I see it in the extern put char. Yes, extern is defined as a keyword. Yeah, 10 here. And then I think I have that in some of these tests. Yeah, like here. It is just the standard like import external, I guess. Okay, so we have the body, so now we compute the next value of the iteration. Yeah, and then this is where 1.0 is handled. Value. Is there a reason why it's initialized to a null pointer here? I guess it's explicit, I guess is why, but okay, so if we defined a step, then step val equals step codegen, and then if it still doesn't exist, then we just return null pointer. And then this else block here just uses 1.0, so step val equals lvm constant fp get context, and then it takes in ap float 1.0. Glad I didn't typo any of that. I guess that's good practice in case the code below changes. That makes sense, yeah. Okay, end cond. This is end con equals end codegen wait. I might have parsed body wrong. This could be a false alarm, but or typed body. I guess no. Yeah, okay. I'm tripping. Yeah, so it's just this is all that's left actually. Wow. So we codegen end, and then if this doesn't exist, return null pointer. Wait, why do we save this but not Oh, I guess we need encond as well later, right? Is that why we're holding on to it? Yeah, we need it for the con branch, but we don't really care about reusing the body for anything. That makes sense. Okay, so we've made the encond. Oh, we need to make the compare. Builder. Codegen. What am I writing? Create FCMP. And this is Station and Cond. Oh, this is like this. This is the same yucky boilerplate from if statements. Let's just change it like this. And then this would be loop cond. Sure, fair enough. So I have the end condition. And now we just finish up the control flow. So we make basic block. Oh, we need to re-get this in case there are more basic block shenanigans in the middle. We can just call it end basic block, right? After basic block, this is base LVM basic block create. Take some context, after loop, and then function. I think that's it, yeah. So then builder, create cond branch. This takes in end cond, which is why we were holding on to it. Then this goes to loop basic block, and then after basic block. And then we set insert point again. Okay, so that wraps up the control flow. And okay, so we need to link up the phi node to this back edge. We need to restore the variable that we shadowed, and then return 0. Okay. Python would say that this returns true if it didn't break anything. I think Python's a little bit silly for that one. incoming, and this takes in next. What did I call next var? Forget about this. Oh shit, I did forget about this. Whoops. Let's put this here. Whoopsie. What was variable again? Var. Okay, fair enough. And this takes. So we add to var step val. And then next var. So then we plug in what here? So we need next var, and then we need loop. We need end bb. So now we just do cleanup. So if old val and named values var name equals old val, else we nuke it. Oh, not old val. No, we don't get rid of it with a no pointer. We get rid of var name. And then we return 0. Why does it return 0? Can you assign the for loop to a variable? I'm not sure actually. Yeah, because variables low-key don't exist yet. So it's like, what is the point of this? I guess since it's like it is just like a control flow. So I guess like from a functional programming perspective, I don't think it really should return, or like it doesn't really make sense for it to return anything. Because I know for loop is like a primary expression, just expression, I think. Oh no, it is a primary expression. So where do I have this defined? Somewhere above here, I think. No, of course not here. Oh yeah, we can add things to the result of the for loop for some reason. So I guess 0 makes sense as like the placeholder value. I guess I don't really see any other value making sense, at least. So like Sure, I guess. Oh wait, no, this is... I scrolled to the wrong part. Got caught straight copying. Unlucky. I guess null value is the closest explanation. Constant. Get null value. That's a double null. Okay. So now we should be able to use for loops. How do I want to test this? So I need to build it, obviously. And then I guess I could just type in the function. What did I mark as comment? What is a comment? Uh-oh. Oh, okay. Ah, that's a comment. Okay. Let's do a quick vim macro. So we select all, norm, and wait. Norm, insert that, enter. There we go. Okay, so then we build kaleidoscope. Let's pass in as the stream tests fib. Oh, right, that doesn't work. Multi-cursor, Vim doesn't have multi-cursor, I think. Does Vim? Oh. Wait, that's pretty neat. Interesting. Okay. I might play around with this then. wait. Okay, well, that's neat. I might play around with it. I don't really see a need for it for the most part though. Let's make a... We're just passing this in like that, and we can make a for loop with this god-awful syntax. For I equals 1, I is less than 10 in... This is gross. Fib I. Okay, let's do this manually. Why is this breaking? Let's start simpler. So 10 in, and let's... Oh, I need to extern. I need to exit input chardy. Let's just steal their code. I keep trying to put in a type on it like a normal person. What? Huh? Okay, let's just for I equals 1, I less than 10 in I. It should automatically resolve to that, yeah. Okay, maybe I messed something up here. This error would be unknown token when expecting an expression. This come from here. Yeah, it could be that. I think it auto resolves to whatever has been I guess whatever is included in the kaleidoscope linking. So it could be that, but even still, even just like this should be working. So then this is big U, aha. Variable expr. Wait, we have variables? Wait. Oh right, yeah, we have implicit variables. Yeah, because I think the only time these are used is with like function parameters, if I remember correctly. Maybe I'm setting named values wrong in here. Yeah, yeah, this syntax is definitely something. I might be parsing wrong even. Yeah, this looks good. And equals. We parse start. It's not a comma. Expect that. We parse end. Ah, wait. I forget to eat the comma, I think. That could be it. Or wait, but then this should still. Wait, this might still break then. Yeah, that should still break. That makes sense. I got rid of int. And types don't exist in this. Unlucky. There's so many things wrong with this language. But it's also supposed to be a beginner language, so like fair enough, but also like ah. Yeah, truly the Python killer. This might be a me killer, I fear. What am I missing? Am I parsing something wrong up here? Am I cogenning the name? Unknown token when expecting an expression. Wait, this should be an S. It should be Kurtok. What if I just make this print straight Kurtok? No, okay. CF printf. String. What's the argument for that? Oh wait, this is an int. Wait, so this is D. Whoops. Oh. Lol. Alright, let's try that again. Let's see where it's tripping up. I suspect it's gonna be something really silly that I forget. Equals 1, I less than 10, and I minus 10. What do you mean? Eh? You make stood C error sad? There was like a very concrete reason that LLVM doesn't like using the C++ IO functions. I forgot what it was. Or I guess IO stream. Isn't there a style guide? Stream. Here we are. Many common implementations transparently inject a static constructor into every translation unit. And also low-key print formatting is kind of nice. No I++, I feel like, or there was like there was the optional component to the thing. I guess I'll try with it. Less than 10, 1.0 in I. I might have missed a whatchamacallit, a get next token somewhere here. Yeah, yes I did. It should be here, I think. And let me just get rid of this print log. Where did I put the print? Oh, the lexer. No, not the lexer, the parser. Right? Wait. It's parse primary, right? Oh yeah, here. Oops. Yeah, I should add debugging next time. Add debugging to the list of tasks. I might actually like set a requirement for myself to use GDB at some point because I have no idea how to use it, and I low-key should learn how. Keep up the good work, bro. Consistency is key. Thank you. This series will be going for quite a while, for better or for worse. For I equals 1, I less than 10. 1.0 in I. Okay, well, that does what it was supposed to do, I guess. LLDB, that's so real. Okay, so then next turn, put char d char. Does this work? It doesn't. Okay, I should probably. I need to figure out how to import that. I think I covered it barely in the last tutorial, or the last chapter of it. Oh, okay, well. Yeah, okay. Then where do I put this? Maybe I should make like a quick runtime library or something, just for fun. Actually, I'll need to do that for my personal compiler anyway, because I'm not going to be implementing the preprocessor yet, at least. That might be smart. Okay. So I think LVM... In here, I think there was the... within the kaleidoscope tutorial. This is in examples. Do they have it in here? No, they don't. Unless it's in here? Oh yeah, it is literally just included here. Okay. Okay, well, that might be the next time task actually, just the runtime library. I feel like that'll be a little fun reprieve from everything. We'll just like we'll add like simple prints and then like call that a day, I guess. Maybe like errors or something. Not that I'll write programs complex enough to use them, but that could be fun. Okay. So I guess the only real way to test this is kind of just checking the code gen. Let's try this with just without the increment. Okay, well that at least parses. So then now we pass in fib, but we need to add the loop to fib. Let's put it in here. Actually, let's just get rid of that. Should make this a function. Fib 2, and then x. Let's add x plus 1 there, because it's one index. Test, let's pass in test fib. Did I miss something? Huh? Let's get rid of this. Oh wait, it's underscore maybe. Yeah, it was underscore. So now we have to disassemble. Okay, perfect. So that's, oh, this has optimizations, but even still, so we jump into loop with the fee. Yeah, so we get fib. So then we increment. Is this going to the correct place? Yes. Right? No. This should be compared to next bar, right? Add temp seems wrong. But the rest of this looks fine, at least. Hey Siash, how's it going? I'm doing alright personally. I've just been tapping away at this. You should return some absurd value from the for loop to compete with JavaScript. Yeah. Maybe just like an explicit NaN. Let's give it -3. Let's do -3 on the output. Let me just cross-check this real quick. I call temp for where is n? Oh. Oh yeah, n is the provided value here. So n here should add temp should be x here. Right? No, wait, no, because this is I see. Wait, I'm so confused by what's happening. I'm gonna run this without optimizations. Hey Janine, how's it going? This is in compiler. Let's make so we run that. Okay. Yes, sir. So that's the call. And then next var, so we add increment to that. Add temp. That's not supposed to. I don't think that's supposed to show up there. I might have tweaked out in the middle and added it. So this would be not parser ast cogen. Oh wait, I should be looking at this in here. I really should not have deleted those files. Let's redo this. Oh, that's not the right one. There we go. What are we adding to here? Wait, what? How is this happening? So we resolve what I is. I is like the current value. Why is this adding x? Oh, wait, I see. Wait. Do I see what's happening? That doesn't explain why it's adding. We have the... So that's the call. It's generated here. So next var is here. What? Wait, what's happening here? So we compare to add temp. That roughly makes sense. So where is this coming from? Add to X? Wait, but when could we possibly be adding to the... I could just be botting out here, alternatively. There might be something just like really silly that I'm missing. Are you adding to I? Yes, but I thought that's what this accounts for. So then why is it also adding to that? Oh, it might be this, low-key. Is it this? It could be this. Wait, but what? Oh, right. Because I told it to do that. That's why it's doing that. Ah. Okay, I just full bought it out. That's all good. Okay, well now we know where that comes from at least. Yeah, the syntax is quite awful. It's not even that though. It's more that I literally told it to add one, and then I forgot that I told it to add one. Interesting that doesn't get constant folded in, I guess. Seems like a really gross place to evaluate that, at least. Okay, so then let's add that back. And then we rebuild. And that should be it, I think, for this section. Right? Yeah, well, I guess it exists here. Yeah, it looks like it got moved up here, which is good. Okay, well, good to see that it at least runs now, in theory. It at least works. There's no real way to print the values. So I guess I will do that next time instead of... What is the next thing that we're supposed to add here? User-defined operators. Sure. Yeah, this will be like a maybe next time thing, maybe next time thing. But the next priority for now, I think, will just be adding the runtime library because I would like to print things. I should have time. I don't think I'm like that pressed for time at least. So the only other thing I need to do is just add this. So then implement for loops, ugly for loops. So yeah, I think that's about it, and I'm gonna call it here for today. Thank you all for sticking around in the stream. It really does mean a lot to me. Make sure you like and sub if you haven't already. If you know anyone that can refer me anywhere, especially with like Google opening up soon, please slide my resume their way, and make sure you connect with me on LinkedIn and follow me on GitHub. Take care all. Take it easy.